Hi, welcome to Chapter 3. I'm Mrs. Kelly. This is Mrs. Tandra. This should be your first video you're watching for chemistry, so make sure that you pause when you need to if you are writing down your notes at the same time. Make sure you rewind if you missed something, but this should be pretty simple for this chapter. We have a lot of things that you've already covered in Science 1. It's mostly about matter, properties, and changes. Let's get started with Section 1. It's properties of matter. Matter, as you know, is anything that takes up space and has mass. And matter that has unchanging and uniform composition is called a substance or a pure substance. So elements can be pure substances and compounds can be pure substances as long as the composition doesn't change. So table salt, what's the composition of that?
NaCl, 1 Na to 1 Cl.
Good. And water, you should all know this.
Oh, I hope so. H2O, 2 H's to 1 O.
And let's challenge you. What's baking soda?
Oh, baking soda is sodium carbonate, which is Na2CO3.
Good. Okay. So remember the differences between matter and a substance. States of matter. You all know these, and you're all going to tell me, but Mrs. Kelly, there's a fourth one, plasma. Yes, there is, but we don't deal with that in chemistry very often, so we're only going to deal with solids, liquids, and gases. So make sure you fill in your chart in your guided notes. Solids, they have a definite volume, definite shape. We have an example here. These are nickel balls, I guess. And they all have definite shape and definite volume. They take up this, each one has their own individual shape and volume. Liquids, we know that liquids flow and that they have a definite volume because they take up the space that they're in, but they have an indefinite shape because they can flow. So see how the water changes shape as it flows throughout this.
You can't compress it either.
No, you cannot compress it. Gases have an indefinite volume and an indefinite shape. Remember, the gas molecules, they are trying to get away from each other. All molecules are trying to get away from each other. So gas molecules are going to spread out as far as they can. This one is a closed container. The gas within it is just the air around us. But gases, all the molecules will be as far apart as they possibly can be. So that is why you don't really see anything.
You can compress gas.
Yes.
It means we can push it down into a smaller volume. So that's why it's indefinite. It flows everywhere.
Now, vapor is used a lot of times interchangeably with the word gas. However, vapor is distinct from gas because vapor is a gaseous state of a substance that is solid or liquid at room temperature. So if we boil water, it's normally a liquid at room temperature. If we boil it, it will turn into water vapor. Now, water vapor is odd because we know that humidity is due to water vapor in the air. So maybe that's a bad example.
Yeah, it works. There's always different things for everything. So just know that vapor comes from once you actually move something from a solid or liquid into the gaseous state. Whereas something at room temperature that is already a gas is called the gas.
Yes.
And which you can tell on your periodic table by the color on the chart. So if you look, it'll tell you what the room temperature is. You'll have black, blue, and possibly red.
Yes.
So especially the ones behind us. Yeah. So just look on your periodic table and then you'll know what state of matter it is in at room temperature.
Okay, physical properties. Physical properties are ones that can be measured or observed without changing the composition of the substance. So basically with physical properties, all you're doing is looking at the substance. You might be able to pick it up. You might be able to use a ruler and measure, but you cannot change the composition of the substance in order to observe these.
So a physical property is going to be a descriptor word. You're going to say a color, the shape, the size, the is it brittle, is it hard, is it pliable, which is, what do we use? Pliable is not the term in science class.
No.
We use malleable, that we can bend things. All right, so
And
you're
ductile.
going to and ductile, nice, because that means we can actually stretch it out into wire. So those are two main types of things that we look for in physical properties. It's a physical descriptor. It's descriptor words you're going to use to describe something.
If you look at the examples in the picture, we have copper and we have sulfur. So copper is on the left-hand side, and it is drawn into a wire, and then it's also in pellets. Well, it's the same color. It will have the same hardness. It will have a lot of the same physical properties, even though it looks different. And the same with sulfur. You can see that, that there are properties that are similar with those, even though they are in different forms.
Okay.
Okay. When we're talking about physical properties, there are two different kinds, extensive and intensive properties. Extensive just depends on the amount of the substance. So these can change, even if you're dealing with the same thing. They can change depending on the amount of substance that you have. So, for example, these two squares of aluminum foil. This one is a lot larger than this one. Okay, so it has a different length. It also has a different width, a different height as this one. Okay, these are extensive properties. Anything to that?
Make sure you know it. It's on your final, and 3/4 of you will miss it.
Yes, make sure you remember that. Extensive properties just depends on the mass. So notice we're dealing with the same things, but they have different shapes to them. Okay, intensive properties. The amount of substance does not matter. So it is unique to the substance. So in this case, we're dealing with aluminum. You can look at the color of aluminum. Okay, it's silver. You can look at the luster of the metal, and it's pretty shiny.
Shiny.
Okay, but it should be the same for both of them. You can also measure things like the density. You could try to melt or boil this, and you would come up with the same point for each of them. All of the properties that don't change based on the amount that you have, those are the intensive properties.
Okay.
Anything to add?
Nope, I think we're good. Continue on.
Chemical properties.
Yeah.
Chemical properties are different. These are the ability of a substance to combine with or change into one or more substances. So I've included some warning symbols that we get on a lot of the chemicals that we get in our lab.
I have to say the corrosive is my favorite.
It's so descriptive. You know what's
Yeah.
going to happen. So some chemical properties, these are not as easy to detect until you start reacting them with other things. But it could be reactivity. It could be corrosiveness, toxicity, flammability. Is it a photoreceptor, and is it a strong oxidizer? We'll talk about oxidizers later on. But does it catch on fire? Does it explode? Is it going to be harmful if it touches your skin? These are all chemical properties.
Excellent. Pretty self-explanatory. Ready? Section 2.
Section
Changes
2.
in matter. Ready? Go.
Okay, physical change. Again, physical properties are things that you can just observe, and you're not changing the composition of the substance. So, physical change is going to be a change to a substance that does not result in a new one. So, I have a picture here. It's hard to see ice, but there are ice cubes in there. Everyone's seen ice cubes melt, okay? It's not changing composition. You are just taking it from a solid form to a liquid form. And then if you boil it, you're going to get water vapor. It's changing to a different form. However, you could still get it back.
All right, so it's just moving through the state of matter is a good example.
Mm-hmm.
The other one is if you rip something.
Yep.
It's still aluminum on this side, and this side you've just changed the shape. Physical changes are pretty much if you start with something and it's still the same chemical compound in the very end, it's a physical change. As compared to the next thing. Oh, or not. Phase
Yeah, talk about
changes.
phase changes really fast. Okay, so a lot of times when we are talking about physical changes, students aren't sure what all of these terms mean. I'm sure you already know what freezing and melting mean, but some students get tripped up with deposition and sublimation. So you have one of these charts on your notes, and it goes between the three main states of matter: solids, liquids, gases. Remember that solids have the least amount of energy, and they are at the coolest temperature for that element. Liquids have more kinetic energy or higher temperature, and gases have the highest for that
Because?
particular one.
They're moving.
Because they're moving. The temperature is a measure of the average kinetic energy.
All right, so solids
Remember
are
that.
moving, but they're pretty much stuck together.
Yes.
They're just kind of like bumping into
They're
each
just
other.
vibrating in place. Yes.
And then liquids, they can actually flow over them. I like to do this because it kind of reminds me of a little dance, a really sad little dance. But they're flowing, and they actually can rotate around each other. And then gases, we don't like it.
Right.
I don't like you.
Yes.
I'm going out of the screen. They want to stay far away from each other as possible. So how do you get from one thing to the other? again, Mrs. Kelly said freezing and melting you're very familiar with. Evaporation and condensation you should be familiar with. You should know it goes between the liquids and gases. The ones you're not so familiar with, deposition and sublimation. So make sure that you've got those memorized for your test.
Deposition is when a gas goes straight to a solid, so it's depositing the solid. And sublimation is when it goes straight from a solid to a gas and it skips the liquid phase. Okay, so all the blue ones, those are cooling down. All the red ones, those are heating up.
That's nifty. I like it.
Okay, chemical changes. Process that involves one or more substances changing into new substances. So terms that you'll hear or read are decompose, ferment, rust, tarnishes, burns, rots. Any of these things are turning a substance into one or more new substances. So an example would be iron and oxygen. Here's an iron pipe. It's reacting with oxygen in the air, and what forms is iron oxide, or what's commonly known as rust. So you don't have the same products as you started. Well, okay, so the reactants are different than the products.
All right, so we can't go from rust and get iron and oxygen back.
No, it'd be difficult.
Unfortunately. So once your car rusts, sorry.
Yeah. So, the law of conservation of mass, Antoine Lavoisier, if I said that wrong, you can correct me, showed that mass stayed the same before and after a decomposition reaction. Okay, you've heard this before, law of conservation of mass. It just means that nothing goes away. The mass is going to stay the same throughout. So, his experiment, he took mercury oxide, which is a red powder, put it in a test tube, and heated it. And what happened was that the red powder turned into silver liquid mercury and oxygen gas. So the picture shows a test tube being heated. That is turning into liquid mercury, and you can see the balloon is filling up, and that's going to fill up with your oxygen gas. So he was able to do this experiment and see that the reactants equaled the products.
Okay, and we will not be doing this in class because mercury is poisonous and
No.
health department doesn't like it.
But we will do another lab with law of conservation of mass. So mass is neither created nor destroyed during a chemical reaction. That is how the law is stated. And again, mass of the products equals mass of the reactants. So this is your first little calculation. If 10 grams of mercury oxide is heated in an open flask and produces 9.26 grams of liquid mercury, what is the mass of oxygen gas produced?
How are we going to set it up?
I don't know. You tell me.
All right. Wonderful. I love math. Okay. So they're telling us our first thing we started with was 10 grams of mercury oxide. So I would write down the 10 grams. And early on, you guys are probably going to write out mercury to oxide. But Mrs. Kelly and I, since we've got shortened little time here, we're going to actually make it into its symbols. So Hg is mercury, and our O charges the little 2 crisscross, gets rid of. Back to your freshman year. Hopefully you remember it. They cancel each other out, so you're left with just that. Now that was what we started with. And then it says, see the and up in there? The and means we're actually going to be separating. That's your equal. Produces means we've got our products. So one of our products is 9.26 grams of liquid mercury. And maybe we should, behind the liquid or the mercury, put our little L symbol.
Sure.
Since it's a liquid and we know that. And then we've got a blank. We're going to have a blank spot or an X, as your algebra teachers would love, grams of O2. And that is a gas, so we can put our little g.
There we go.
All right, so if your products have to equal your reactants and your reactants have to equal your products, your basic math here is going to be a subtraction problem. You're going to subtract 10 grams minus 9.26 grams and get 0.74 grams. And you must write your grams and label whatever your answer is. Get used to it now early in class because you will have to label everything from here on out.
Or you will get confused. It's not just because we're checking for it, it's so that you know what you're actually talking about when you give us an answer. Okay, so that's really easy. This is the easiest calculation you'll probably do in this class.
Yeah.
Aside from partial pressure.
Yeah.
Okay, so if you have questions on this, we will do more in class. But this is this is all of section 1.
And 2.
And 2. Okay, so we will see you next